Hi guys, I'm going to show you an example dynamics problem that isn't asking for anything special. I just want to be able to show you all of the steps. Okay, so we have a 70 kilogram box being pulled by a 400 Newton force at an angle of 30 degrees above the horizontal, and the force of kinetic friction is 75 newtons. We're going to draw a quantitative force diagram, and we're also going to determine the acceleration. Let's draw our qualitative force diagram first. Remember, force diagram is just FBD. So we're looking at our box. It is on Earth, so it has a gravitational force. It is on a surface, so that's going to be Fn. Let's make our dot more like this so they look a little more equal. Okay, we also have tension, and also we have friction. And the reason the friction is this way is because it's really like down here touching the surface, right? Okay. We'll plug in our values later once we know more of them, okay? But for now, we do know that our force tension is 400 newtons, because that's how much it's being pulled by. And we can calculate our force gravity, because that's just mg, and that's just going to be 70 times gravity. So we'll just do 10 for gravity. So 70 times 10, which is 700 newtons. We don't know the other ones yet. We kind of have to solve for it, okay? Let's make a sum of the forces equation. Let's do one in the x direction first. So in the x direction, I have just one component of this force tension, this x component right here. If this is our angle, and we're looking for this part, that is cosine because it's adjacent, so this is going to be ft cosine theta. So we have ft cosine theta in the x direction, and we also have force friction. We're going to say that this way is negative just because it's opposing the motion. So minus force friction, and the object is accelerating, so this is going to equal mass times acceleration, because remember, the sum of your forces equals to mass times acceleration. That's Newton's second law. All right, so next up, we want to do a sum of the forces in the y equation. In the y direction, we have a force normal. We have force gravity, which is in the negative direction. And we also have, in the positive direction, so we're going to add it, the y component of ft, which is going to be ft sine theta, because it's opposite. Okay, cool. So we want to find acceleration. We want to find this. Well, that's terrible. We want to find this. Okay, so we need to get acceleration by itself. But I don't have enough information to really start doing that yet. I think I need to figure out what force friction is first, so that I can plug in and actually have some values to work with. So let's find force friction. We know that force friction is equal to mu times force normal, so we got to find force normal. If I go back to our sum of the forces in the y direction, it's not moving in the y direction, right? It's balanced that way. So if it's balanced, that means we can set that equation equal to 0. Now we can solve for force normal. We can say force normal is equal to, moving these guys to the other side, force gravity minus ft sine theta. Fg, we know, is mg. Force tension, we know the value was 400. And we know that our angle is 30 degrees. So let's just plug in some values. So our mass is 70 kilograms. Gravity is 10 minus our force tension, which is going to be 400 times sine 30. That's squished, but let's plug it in the calculator. So 70 times 10 minus 400 times sine of 30. Make sure your calculator is in degrees. So that's going to equal 500 newtons. Great. So we know that our force normal is 500 newtons. Now we can find our force friction. Force friction is equal to mu. Oh, wait. We were told our kinetic friction. It's 75 newtons. I still wanted to show you the steps anyway. Because now, since we know that force friction is 75 newtons, we know that this is equal to mu times our force normal. We can now find out what mu is. Okay, so if I have force friction equals mu times force normal, I want to get mu by itself, so I'll say force friction divided by force normal is equal to mu. Force friction is 75, normal is 500, so 75 divided by 500, that's going to equal to 0.15. Ta-da! Look, another thing you can solve for using these steps. Okay, now let's get back to the root of this. We want our acceleration. We know all of our forces now. Let's return to this equation right here where we actually have an acceleration. Now we know what our force friction is. It's in the problem. And our force tension, they told us that. We can solve for acceleration. So force tension cosine theta minus force friction is equal to mass times acceleration. We want to get A by itself. Let's divide m to the other side. Now we can plug in our values. 400 times cosine of 30 minus 75 divided by our mass, which is 70 kilograms. Let's plug this in. Use parentheses, be careful. 400 times cosine of 30 is your calculator in degrees, minus 75 divided by 70 is equal to 3.877 meters per second squared. Okay. Just to make it perfectly clear, here are the steps that we did. Our first step was make an FBD. Our second step was to write down what we know. We put that on our FBD. The third step is our sum of the forces equations. And then the fourth step is algebra. Okay? If you draw an FBD, you think about your knowns, and you create the sum of the forces equations, and you do it properly, you can solve any problem in dynamics you need to. Hope this was helpful.